in this problem, we're required to find the intervals where the function is increasing or decreasing. So we're going to apply the first derivative test. So let's maybe discuss the recipe for the first derivative test. So I'll write first derivative test. Let's understand how does the first derivative test work. So the first derivative test, it has the following steps. Step number 1, you're going to find f prime of x. And then step number 2, you're going to find f prime of x equals to 0. And then step number 3, you're going to have to solve for x. And then when you solve for x, in this case, you're going to get what we call the critical point. The critical point from solving for x in this point. And then after solving for that critical point, you're going to go for step number 4, which you're going to plot a number line. And then the number line is going to look like something like this. And then minus infinity, plus infinity. And then you're going to plot your critical point. And then, right, so that's what you're going to do. And then number 5, we're going to determine where the function is increasing or decreasing. Determine where the function is increasing or decreasing. Right. So, but let's understand more in just to understand why should we use this stuff with the first derivative test. What is the first derivative test used for? We already saw on the previous video that it's also used for finding the absolute extrema, right? And then the first derivative test is also used to find critical points, right? That is very, very crucial, critical points. And then it's also used to, we also use the first derivative test to determine local mean slash max, local mean or local maximum, and then intervals where the function is increasing or decreasing. So those are some of the points where we use the first derivative test, and I want to use it in this problem just to see how it's going to help us. So we're given the function f of x is equals to x squared minus 4x plus 5. So let's quickly copy this problem. I'll just try and copy it, and then let's come back down here. I'll plot it here. I'll paste it here. So we wanna understand, right? So step number 1, we said we're gonna find f prime of x. In this case, f prime of x is 2x minus 4, right? And then step number 2, we're gonna say f prime of x is equals to 0. And then we have 2x minus 4 equals to 0. And then step number 3 is just to solve for x here. So this becomes 2x equals to 4. Divide both sides by 2. Divide both sides by 2, cancel. X is equals to 2. And then we know that this is our critical point. And then step number 4 is to plot the number line. So to plot the number line, you're going to plot the number line like this. And then you have minus infinity and positive infinity. You plot the 2, right? So from this, we want to determine, step number 5 is to, on the same number line, we need to determine where is this increasing or decreasing. So we're going to look for numbers between minus infinity and 2. I'll look at 1. And then we want to look for another number between 2 and positive infinity. That's like 3. So I'm going to take this number, substitute them onto the derivative, and then check whether I'm getting a positive answer or a negative answer. So let's start with f prime of 1, right? Which is equals to 2 times 1 minus 4. F prime of 1 is equals to 2 minus 4, which is equals to minus 2. And then we can see that the answer that we got there, it's minus 2. So that means that on this section, we have a negative, right? And then let's also substitute f prime of 3. So between 2 and positive infinity, we have 2 times 3 minus 4, which is equals to 6 minus 4, which is equals to positive 2. And then we can see that on this part, we have a positive. In actual sense, this is moving from, it's decreasing at this point, and then it's increasing at this point. So now we can determine where is our interval of decreasing and increasing, and then do we have a local min or a local max. So we can conclude that it's decreasing. This function is decreasing between minus infinity and 2, and then this function is increasing. You can already see it's increasing between 2 and positive infinity. And then we also have a local mean at x equals to 2, right? And then if we want to find the actual point of the local minimum, we can actually substitute these two into the original function. So to find the actual point, so we said f of 2 is equals to 2 squared minus 4 times 2 plus 5, and then f of 2 is equals to 1, right? So that means we have the local minimum at f of 2 equals to 1. I just want to verify this on my calculator. Minus 4 times 2 plus 5. Yes. So we have a local minimum at 1. And then if you were to plot this graph, you would see that that means that you have the turning point at this point 2 and 1. Right? So that's the turning point. This is where you have your local minimum. Right? So yes, guys, so this is how you apply the first derivative test on this kind of on this kind of stuff. So yeah, if you need more clarity on this question or in approaching the first derivative test, you can leave a comment below, and then I will be able to assist you. And then yeah, just click the subscribe button, and then I'll see you in the next video.